Hello dear students, in today's class or in this video we are going to solve the sixth question of exercise 6.2 from the lesson lines and angles. So the question is, in the figure 6.33 PQ and RS are two mirrors placed parallel to each other. An incident ray AB strikes the mirror PQ at B. The reflected ray moves along the path BC and strikes the mirror RS at C point and again reflects back along CD. Prove that AB is parallel to CD. Okay. So in this question, before we solve this question, we just recall what we have learned in our 8th standard in physics in the lesson light. Right. So here there is incident ray, there is reflected ray, there is a mirror. Right. So here there are two mirrors, PQ and RS are the mirrors, and this AB ray is falling on that PQ mirror and it gets reflected back on the second mirror. And from the second mirror it's again get reflected through a D point, right? So like that, this AB is the incident ray for PQ mirror and BC is the reflected ray for PQ mirror. Okay, then this BC is incident for RS mirror and CD is the reflected ray for the RS mirror. Okay, so you have to prove that this AB line is parallel to this CD line. That thing we have to prove in the last question of our second exercise. Let's see how to prove it. We'll do it in a proper way. First we'll write the given data, next we'll write what we have to prove, next we are going to go for the proof. If there is any construction we'll do and later we are move on to the proof. Okay, solution. In the solution part given is PQ is parallel to RS, so that is given. Now AB, BC and CD are the rays. Obviously they are rays, incident, reflected, they are the rays. Next, okay, we have to prove that this AB line and this CD line are parallel to each other. That thing we have to prove in the given solution. Okay, for this one, let's do a simple construction. That construction is draw BM perpendicular to PQ. So from the B point, draw a straight line. Okay, so name the other end as M, which is perpendicular to PQ. Perpendicular means it will form 90-degree angle on both the side of the perpendicular. Right, in the same way, draw CN, just name this as N, perpendicular to RS. So here also it is forming 90-degree angle both the sides. So that construction we will use to solve this question. Okay, the solution of the question. So after construction with this incident and reflected rays, our perpendicular is forming angles like this. Angle 1, angle 2, angle 3 and angle 4. So this is CN perpendicular and this is BM perpendicular. Okay. So BM parallel to CN. In the proof part, we are writing that BN and CM are parallel to each other because we know that PQ line and RS line are perpendicular to each other according to the given question. Whenever you draw perpendicular for the parallel lines, if you are drawing the perpendiculars for the parallel lines, that perpendicular will also be parallel to each other. So that is the concept of drawing the perpendicular between the parallels. Okay, now that one we are going to consider as the first part of our proof, that is BM parallel to CN. Okay, the second part of the proof, angle 1 is equal to angle 2, angle 3 is equal to angle 4. Okay, because loss of reflection. Here we are using the physics again. We are using the loss of reflection. With the help of loss of reflection, we can write that angle 1 is equal to 2, angle 3 is equal to angle 4. So remember the law of reflection. Angle of incidence is always equal to the angle of reflection, isn't it? So here, if we take this AB ray as incident ray and this BC as the reflected ray, and if we consider this BM as a normal. So just this thing you have learned in your 8th standard physics, right? So by this, the angle formed by the incident ray is incident angle, angle formed by the reflected ray is reflected angle, right? According to the laws of reflection, the angle of incidence is always equal to the angle of reflection. That thing we already learned, isn't it? So using that law, we are writing angle 1 is equal to angle 2. Same thing happens for 3 and 4 also. For RS, BC is the incident ray and CD is the reflected ray, right? So incident angle is angle 3, reflected angle is angle 4. So incident angle 3 is equal to reflected angle 4. Okay. So let us consider this as the first relationship for our solution. Now move on to the next part of the solution. In the next part, we are going to write that angle 2 and angle 3 are equal. Okay. So in the first part of the proof, we wrote that BM line is parallel to CN line. Okay. If BM and CN are parallel to each other, then BC will be considered as the transversal between them. So by the transversal, you are getting a Z shape of angle here. Z shape of angle, we are getting angle 2 and angle 3. As we all know, between the parallel line, if you have any transversal, then definitely you are going to get the alternating angles by the transversal, isn't it? So here also angle 2 is equal to angle 3. So let us take this as the second relationship. Now using the first relationship with the help of laws of reflection and the second relationship with the help of parallel lines and alternate angle properties, we are going to continue our solution. That is, by using 1 and 2, angle 1 is equal to angle 2, but angle 2 is equal to angle 3, but angle 3 is equal to angle 4. So by 1 and 2, we came to know that all these 4 angles 1, 2, 3, 4 are equal to each other and they are having the same measurement. That thing we came to know with the help of first relationship and the second relationship. Here we are considering two angles because all the angles are equal. Whatever angles you add, you are going to get the same sum both the side. So here 1 plus 2 and 3 plus 4 I am adding. Okay, if angle 1 is 30 degree, then 2 is also 30, 3 is also 30, 4 is also 30, right? If angle 1 is 50, 2 is also 50, 3 is also 50, 4 is also 50, isn't it? So you add 1 plus 2, you will get the same answer, you will get 3 plus 4, you are going to get the same answer. So we are pairing the angle like this. If we consider 1 plus 2, that 1 plus 2 is our angle ABC, isn't it? Whole angle ABC, and 3 plus 4 is our angle BCD like this, right? Okay, so that two angle will become equal. Okay, so when these two angles become equal, so between these two angles like this you have a line, right? And here also you have a line and here also you have a line, isn't it? So if we consider BC as a transversal, you are getting angle ABC and angle BCD on both the side of your transversal line, isn't it? And if you are getting the angles both the side of your transversal line, means the remaining two lines which is connecting to this transversal are always parallel to each other, right? So using that concept, we can write that AB is parallel to CD. So that much only the solution for your question number 6. Okay, so let's recall the solution one more time. BM is parallel to CN because perpendiculars on the parallel lines are always parallel. Next, by that BM parallel to CN, and by using the laws of reflection, we wrote angle 1 is equal to angle 2, angle 3 is equal to angle 4. Consider that one as 1. Just it is a quick recap. Okay. Next, BM and CN line are parallel to each other. Therefore, angle 2 and angle 3 are equal. They are alternate angles. Next, using 1 and 2, we'll write that all the 4 angles are equal to each other. And considering adding two angles, 1 plus 2, 3 plus 4. 1 plus 2 means it is ABC angle, 2 plus 3 means it is BCD angle, right? So, these angles ABC and BCD are on the either sides of BC line, which is a transversal. So, the connecting lines of BC are AB and CD, which are parallel to each other. So, that is the proof. Okay. Hope you understood the solution. Thank you.